Hello everybody, welcome back to another problem. This is from the Geometry Through Competitions book, the concept of this problem, and you can find it on mymathcouncil.com, so be sure to check it out. So we have that O is the center of the circle, and if the diameter of the circle O is 22, we want to find the length of PO. The diameter of the circle is 22. That means we also know that the radius would be 11. Now let's see what we can do. Okay, so right here I just formed a triangle, and let's call this point as Q. And what we know about OQ is that it's actually the radius, because O is from the center point of the circle and Q is a point on the circle, so OQ must be 11. Now let's draw another line. Okay, so we see that we just formed an altitude of this triangle. So these are both, this angle is a right angle and this angle is a right angle. PQ is equal to 12, if you saw in the beginning of the problem. Okay, now let's create another point. Let's just call this R, and what we notice is from the altitude we created, if we actually extend it, we can see that it's perpendicular. You can see that it's perpendicular from the chords to the chord, because we have the other two perpendicular. Sorry, I'll fix that. That means if it's perpendicular, that means it's also a bisector. So we know that RQ equal to 18, but so let's make another point. Let's make this S. So we know SR equals SQ equals 9. So I'm just gonna get rid of this 12 here. I'm gonna rewrite this as SQ as 9. And if SR is 9, that means SP must be 3, so that this entire SR is 9. So let's find OS. So we can use Pythagorean theorem. OS squared plus 9 squared equals 11 squared. OS squared equals. Now that we have OS as root 40, we want to find the length of PO. Let me write down this P, which is this length. So we have two legs of a right triangle given, so we can use Pythagorean theorem again, which is 3 squared plus OS squared equals PO squared equals 49. So therefore PO equals 7. And that's our answer. Thanks.